Okay, now we have question 2, which looks at sequences and series. Question 2 and 2.1 says, given the geometric series 7x and 36, so given 7x, 63, not 36, and they tell us that's a geometric series. Find the possible values for x. Okay, now we know with a geometric sequence or series that this has to be true. Term 2 divided by term 1 must be equal to term 3 divided by term 2 for it to have a common ratio, right? Okay, and that's the same as term 2 is x divided by term 1, which is 7, must be equal to term 3, which is 63, divided by term 2, which is x. Now you see we've got an equation with only one variable, so we can just straightforward solve that. So let's do that here. Okay, we'll multiply both sides by x and 7. That'd be the easiest way to do it. So x times x is x squared, and 63 times 7 is 441. So now the square root of x squared is x, equals the square root of 444, which is 21, but it's only 21, it's plus or minus 21. That's our answer. So all you need to know is that for a geometric sequence, this has to be true, and you can solve that. Question 2.2. That says if the first term of a geometric sequence is 15, so if we have that term 1 is 15, and if the second term is 10, here's the term 2 is 10, then calculate calculate 2.2.1 term 10. Yeah, so we have told to calculate term 10 if we know term 1 is 15, term 2 is 10, and we know that it's a geometric series of said. Okay. So to find term 10, we need to know what the rule is for the general, what the general term is. We need to find out what Tn, the general term, the nth term, is equal to for a geometric sequence. It's equal to a times r to the power n minus 1, where a is our first term, which equals 15, and r is our common ratio, which is term 2 divided by term 1, and that is 10 divided by 15, which equals simplified 2 over 3. Okay, so there we've got an R and our A. Okay, so that's Tn equals 15 times R to the power n minus 1. So for term 10 specifically now, we can say that term 10 is equal to A, which is 15, times R, which is 2 over 3, to the power n minus 1, 10 minus 1, which is 9. Okay, and that, if you simplify that, you get close to, well, you get 95,855 over, oh sorry, my bad, it's an incorrect calculation. Let's just erase that. You get 2,560 over 6,561. And if you want to know that I've calculated this on the calculator, that it's approximately equal to 0.39. So there you go, there's your answer for that one. Now question 2.2.2, it's a continuation of this question here. They ask us, what is the sum of the first 9 terms of that sequence? Okay, the general rule for the sum to n terms in a geometric sequence is a times r to the power n minus 1 all over r minus 1. Yeah, we know a, we know r, and we know n in this case, which is the 9. So let's calculate. As 9 is equal to a, which is 15, times r, which is 2 over 3, to the power n, which is 9 minus 1, all over r minus 1, 2 over 3 minus 1. That calculated is equal to 95,855 over 2,187, approximately equal to 43,83. So all you need to know is this here is your that's your formula for your sum to n terms of a geometric sequence, and over here is your formula for the nth term of any geometric sequence. And that'll help you a lot with these calculations, and then you can just type into your calculator or work out in your head if you like the answers to the rest of the calculations. Now, question 2.3. They give us a certain sequence. They say given 0, negative a half, 0, 1/2, 0, 3 over 2, 0, 5 over 2, 0, etc. Given that, 2.3.1, find the 191st term of the sequence. So term 191. At first glance you think you might have to work out a general rule for the whole thing. But we can see that every odd term is a 0, and every even term also is just a pattern where the constant difference is 1. It's an arithmetic sequence that's just increases by 1 the whole time. Negative a half to a half to 1.5 to 2.5. It just increases by 1 all the time. So now for term 191. 191 is an odd number, so that means it's an odd term. And every odd term is equal to 0. Well, it's just as easy as that. Now 2.3.2. The question is, what is the sum of the first 500 terms? Okay, now we do have to be careful, because we saw that you can split them up into different sequences. You split it up into even and odd sequences. So the sum of the first 500 terms of the total sequence, I would just rewrite that as the sum of the first 250 odd terms plus the sum of the first 250 even terms. Okay, so the odd terms we said are all 0. So that will just be, the sum of the first 250 odd terms will just be 0. But now the interesting part is the 250 even terms. So let's find a general rule for that. Okay, the sum to n terms in an arithmetic sequence is n over 2 times 2a plus n minus 1 times d. Okay, there we go. So now, the first term in this arithmetic sequence is negative half. So let's say, okay, let's apply the sequence right here. N over 2, n which is 250. It's 250 over 2. 2 times the first term, which is negative a half, plus n minus 1, 250 minus 1, times d. The common difference, it's 1. It increases by 1 all the time. Okay, so that's just 1. Now let's calculate this. Okay, so 250 divided by 2 is 125. And 2 times negative a half is negative 1, plus 250 minus 1 is negative 1, plus 249, that's 248. And what is 125 times 248? 125 times 248, that is equal to 31,000. As simple as that. Okay, next question is 2.4 now. Now we are given this symbol, which means the sum from k equals 2 to 20 of this expression, 4x minus 1 to the power k. Okay, 2.4.1. Let's see what they have for us. Okay, calculate term 1 if x equals 1. So find the first term if x equals 1. Okay, this is quite nice. First we can just use the x equals 1 in that equation and simplify this. So from k equals 2 to 20 of the expression, 4x minus 1. 4 times 1 minus 1 is 3. That's just 3 to the power k. Oh, that's quite simple. Now what is the first term you'll do? You'll start with whatever k equals at the bottom here. That's your first value for k to plug in. So it'll be 3 to the power 2. 3 squared, which is 9. There you go. 2.4.2. For which values of x, okay, for which values of x will this, okay, let me just rewrite that, will this k equals 1 to infinity of 4x minus 1 to the power k exist. Okay, so for which values of x will this expression exist? So we see it's a summation to infinity of a geometric progression because it's to the power, it's a power increase. So what do we know for the sum of infinity? General rule, the sum to infinity of a geometric progression is equal to a over 1 minus r, right? But that's not all. We have to remember that r has to be between negative 1 and 1 for that to be true. So this is the part we're going to use. We're going to find out what r is in this case, and then just plug it in here. Okay, so let's see. R is equal to term 2 divided by term 1, right? Term 2 over term 1. Okay, so the second term in this case would be if you plug in, well, let's do term 1 at the bottom. Term 1 would be when you plug in the 1, the first value here. So the term 1 would just be 4x minus 1 to the power 1. Okay. Term 2 would just be 4x minus 1 to the power 2. So if you divide them, what happens? This happens. So we're left with 4x minus 1 as our ratio. So now we just need to put that instead of the r. We replace it by our ratio 4x minus 1. So we need to do this. Negative 1 has to be smaller than 4x minus 1. Ooh. Rewrite that. Negative 1 smaller than 4x minus 1 smaller than 1. Okay, take the negative 1 across. It becomes negative 1 plus 1, which is 0. And 1 plus 1 becomes 2. And now remove the 4, divide both sides by 4, 0 divided by 4 stays 0. That's now x, and 2 divided by 4 is 1/2. There's your answer. So again, here the important part, knowing this formula. The sum to infinity is the first term divided by 1 minus the ratio, as long as the ratio is between negative 1 and 1. Because if the ratio isn't between negative 1 and 1, we've got what's called a divergent series. And you will never approach an answer for that. It'll just be infinity or negative infinity. Okay, and that was it for question 2.